from West Virginia Public Broadcasting.
Support for the following is provided by the West Virginia Department of Education and West Virginia Public Broadcasting.
Hey everyone, it's Education Station, the show where we invite teachers from all across West Virginia to submit videos of themselves teaching their favorite lessons. In today's episode, we've got 3 exciting lessons about chemical bonds, energy, and coping skills. Well, hello and welcome back everyone. I'm your host, Alex Milanese, and we're kicking things off today with an exciting science experiment. Miss Pruitt has a fun way to demonstrate how chemical bonds work. Let's check it out.
Hi, I'm Rebecca Pruitt. I'm a junior at Princeton Senior High School, and I'm part of the Careers Education program at Mercer County Tech Center. Today we'll be doing a science experiment with milk, food coloring, and dish soap. Milk has fat in it, and it's connected by bonds. These bonds can be compared to holding hands. The food coloring floats on top of the fat. The dish soap breaks up the bonds or breaks the hands apart. That is why we use dish soap to clean dishes. Let's go try it out. So with this experiment, what you need is milk, food coloring, some Q-tips, some dish soap, and I have a plate to pour my dish soap on top. I already poured my milk into the bowl. This milk right here is 2% milk. That means it's 2% less fat than most milks. This milk is probably the most common milk, and it comes in the blue tab jar. What you're gonna do is take your food coloring. You're gonna put different dots around the bowl. You wanna spread it out to get the most color. You can use as many colors as you want or as less colors as you want. The next thing you're going to do is take your Q-tip. You're going to put a little bit of soap on top of your Q-tip. You're going to take your Q-tip and touch all the colors. Notice how the colors are breaking apart and how the bonds of the fat are breaking apart. You can touch all of the colors as many times as you want, and they'll still do the exact same thing. Let's try a different milk. Now we're going to try skim milk. Skim milk is fat-free milk. I'm interested to see what's going to happen since the fat is broken apart. What do you think is going to happen? Just like the 2% milk, we're going to get our milk and pour it in. This milk usually comes in a pink jug. The next step we're going to repeat is put our food coloring in. Remember to spread it out to make a better picture. Take your Q-tip and your dish soap and get some on top. Let's see what happens. So even though it was fat-free, the dish soap still broke apart some of the bonds. These bonds look to have a faster expansion than the other one. That's interesting. Let's try whole milk. Whole milk has the most fat out of all the milks. It has 8 grams of fat in it. This milk usually comes in a red jug. Just like the other steps, we pour the milk into the bowl. We put food coloring all around the milk. We get our Q-tip and put some dish soap on top of it. Do you think this reaction will be fast or slow? Let's try it out. This reaction was pretty fast, just like the other ones. The last milk we're going to try is almond milk. Almond milk is a plant-based milk, and it's made from almonds. The other milks we were using are from cows. Notice how the almond milk is kind of darker. Just like the other steps, we poured the milk into the bowl. We're now going to take our food coloring and make specks throughout the milk. We're going to take our Q-tip and get some dish soap on top. And we're going to touch the specks just like before. Notice how it's not separating as fast as the other milks. Why do you think this is happening? Let's compare all the milks now. The 2% was the first milk that we did. Notice how the colors are combined, but not as much as the skim milk. The skim milk was the milk that had no fat in it. Look how all the colors are combined and you barely see any white. The whole milk is the milk that had the most fat in it. Notice how the colors didn't combine and you can still see some white around. The almond milk, just like the whole milk, didn't combine. I wonder why that. Do you think it's because it was a plant base? Or do you think it's because it has the most fat in it also? After we compared all the milks, you can now see that the fatty milks have a stronger bond than the skim milk or the fat-free milk.
Thanks, Ms. Pruitt. All right, now for our next segment, we're going to continue to learn about science, but this time we're going to be taking a look at energy and how it affects our daily lives. For more on this, let's go visit Ms. Sinisi.
We're going to look at energy in this video. Still simple physics, but energy. What is energy, right? It's the ability to do work. We just talked about work in the last video. Work is force times distance, right? So it's the ability of you to use a force to move an object, yourself, something, a certain distance, right? Modern civilization is possible because people have learned how to change energy from one form to another and then use it to do work, right? I've given you some examples here, 7 examples of what you might use energy to do. You might use energy to walk, run, ride a bicycle. All of those you use energy. You might use energy through your car as it's moved along the road, or boats as they're moved through the water. When you cook food on your stove, that you're using energy. When you make ice in the freezer, when you light your home, your office, any place you go that has lights. When you manufacture products, when we make products, and even when we send astronauts into space. All of those things we're using energy. We're changing energy from one form to another. Here are the forms of energy: heat, light, motion. Then we have electrical energy, chemical energy, and what's called gravitational energy. Those forms are grouped into two general categories, which we'll look at specifically here in a moment. The two big categories are potential, right? That's stored energy. Someone says you have a lot of potential. What they're saying is there's something in you that they know looks good, or that will be able to do work, or that will succeed. That's your potential. That's energy we're storing, things, qualities you might store. And then we have kinetic, and kinetic means to move. That's our working energy, right? Our kinetic energy. Energy can be converted from one form to another. I just gave us this example because we're pretty much familiar with coal. And within coal, there's stored energy. That's potential, right? It's in there. And then that energy is changed to chemical energy. When we convert that, when we start to burn it, then we take those chemicals to light our home. So then it's converted into electrical energy. So we're just changing forms of energy here. Can you think of another example where you've changed energy? What about boiling water? When you put water in a pan, and how does water boil? How do you know it's boiling without sticking a thermometer in there? You see all those bubbles coming up. Essentially what you're doing is taking and adding energy to the water molecules, and the more energy they get, the faster they move. Not more faster. The faster they move, and they start to jump around, right? And then they start to cause the water to boil. Once they get enough energy, they leave the surface as steam, right? So we're just adding energy into that situation. You could think of 100 examples, I'm sure, of energy. Sorry. Sources of energy. We have these two sources. We have what's called renewable energy, and that's energy that can be replenished. If you're going to go for a walk or a run, you may be able to run a mile, go home, right? Rest, maybe eat, then you can go run another mile. That's renewable energy. It can be replaced. We also have what's called non-renewable, and non means not, right? So this is energy that cannot be replenished. Once it's gone forever. So renewable energy is useful energy collected from resources that are naturally replenished on a human time scale, meaning during someone's lifetime, right? We have carbon neutral sources. Sunlight is a carbon neutral source, wind, rain, tides, waves, and what's called geothermal heat. Those are all renewable types of energy. The non-renewable ones are the ones we can't get back once we use, like coal and natural gas, oil, or even nuclear energy when they're splitting those atoms, right? Once these resources are used up, they cannot be replaced. And that's a big problem for humanity because we're currently dependent upon these sources, and once the supply runs out, then what happens to humanity? Excuse me, I'm going to get a quick drink. The next lesson that we do here on the channel is going to be on these resources, the greenhouse effect, right, and global warming. So let's check out the next page. I told you we would get back to the potential and the kinetic. I'm sorry, I just got water on that. Potential energy. An object can store energy as the result of its position. Here's a crane, and it has the wrecking ball attached to the crane. When that ball is pulled back and it's no longer moving, the energy is stored in it, here in its elevated position. That's potential energy, right? When we let that ball go and it moves from here, and up, that's kinetic, because it's moving, right? An object that has motion, whether that motion is vertical or horizontal, has kinetic energy. So here it's potential. It starts to move, kinetic. It'll stop for a millisecond. That's all potential again. Kinetic. As long as it's moving, it's kinetic. This energy is what's called translational kinetic energy, and it depends upon two variables: the mass of the object, right, and the speed of that object, or the velocity of that object. Because kinetic energy is 1/2 the mass times the velocity squared of this object. That's our equation for kinetic energy, right? Gravitational potential energy, and we're going to abbreviate it GPE, is the energy stored in an object as the result of its vertical or horizontal position, right? It's vertical position or its height. The energy is stored as the result of the gravitational attraction of the Earth for the object. We all know about gravity, right? If gravity wasn't holding you down or anything down, it would just float off into space. So that's a force that's pushing down on you. We looked at forces in the previous video. There's a direct relationship that exists between this gravitational potential energy and the mass of that object. So the more massive an object is, they're going to have greater gravitational potential energy. If we had a 1,000-ton block here, it's going to have more gravitational potential energy than a 1-kilogram rock because of that force. There's also a direct relationship between gravitational potential energy and the height of that object, right? The higher the object is elevated, the greater that gravitational potential energy is. So our equation is mass times g times height. Mass, m, would be equal to mass of the object. H is the height of the object. And this g here is what we call the gravitational field strength. And that's 9.8 newtons per gram on Earth. A lot of people call that the acceleration of gravity. If we went to the top of the Empire State Building and we dropped the penny, and we dropped the feather, and we dropped the bowling ball, those are all going to fall at 9.8 meters per second squared. Anything falls because that's our gravitational potential energy to Earth. Lastly, let's look at an example just so you kind of understand. So we're going to try to determine the gravitational potential energy of the object. The first thing we need to do is to make something zero height. Typically, we're going to use the ground as zero, right? We're going to arbitrarily select the ground. So here's the ground. Then I have this building, and I have a ball sitting on top of this building with a mass of 2 kilograms. I arbitrarily think this building is 6,000 meters tall. So our potential energy, we take the mass of 2 kilograms of the ball, 9.8 newtons per kilogram, that's our G, our gravity, and 6,000 meters this ball is up in the air. So our potential energy is 117,600 joules, right? That's our unit of energy. So when we're looking at this, let's kind of do a practical application. Why would you weigh more on Earth than you would on the moon, right? You're you. So if you're here or on the moon, you're not changing. What's changing here is your weight, and your weight is just your mass times gravity.
Thanks, Miss Sinisi. Now, I think we can all agree that this last year has been challenging. Whether you're a young child or a high school student or an adult, we've all had our routines completely changed. As a result, we're all dealing with lots of emotions that can sometimes be difficult to deal with. So in our final segment, Miss Hayes is going to discuss ways to process those feelings. Let's check it out.
Hi, my name is Mrs. Hayes and I work at the West Virginia Department of Education. You know, a lot has been going on in the world over the past few weeks. I'm sure things are different in your life. Things have really been different in my life. What's been different for you? Maybe you're staying home more lately. I bet your school has been closed. Are you missing your teacher and your friends? Maybe you haven't been able to play with your friends like you used to. Do you know why there have been so many changes lately? You may have already heard, but there is a virus in our world called COVID-19. Many people all over the world are staying home to prevent the spread of the virus. You may have already heard about COVID-19 because it's been talked about on the news a lot, and your family may have been watching. We won't always have to stay home just until the virus has stopped spreading so fast. There's a lot we can do to stop the spread of COVID-19. We can stay away from crowds, and we can wash our hands when we come in the house, before we eat, and after we use the restroom. Also, when we cough or sneeze, we can cover our mouth with our elbow like this. With all the changes that have been taking place, I bet you're experiencing a lot of thoughts and feelings. I have too. I have felt happy to be safe in my home. What about you? I have felt happy to be able to spend time with my family and my dog. What about you? Have you been spending time with your family lately? I hope you've had time to read books and play games and work on school. I have felt energized because I've been able to take walks and be outside more lately. What about you? Have you been able to play outside, maybe with your brother or sister? Have you been able to ride your bike or maybe go for walks with your family? I hope so. I've experienced other feelings too. I felt frustration. That's a big word, but it means it's something like anger. I felt frustration because I've not been able to go to work or church or even to the store when I want to. I've also felt sad because I've not been able to see my parents or my mother-in-law or my brothers and their families. Have you felt sad lately? You know, I'm sure you've had a lot of different feelings lately. Here are some cards that show different emotions that people might experience. Now this first card shows a girl. What kind of feeling do you think she has? She is surprised. We can tell she's surprised because she has a surprised face. All right, here's the next card. How do you think this girl feels? If you guess sad, you're right. We can tell she's sad because she has a sad face and she has tears. Look, even the sun is sad. Now what about this girl? Did you guess happy? You're right. We can tell she's happy because she's smiling. You might have guessed loving too because she's hugging her cat. How do you think this boy feels? He feels scared. He has a scared face. What does your scared face look like? What about these two? These children feel thankful. You may be thankful when you get a present, or maybe you're thankful when your mom or dad cooks you dinner. How does this boy feel? He feels lonely. Look, he has no one around him. He's all alone. What about this boy? How do you think he feels? He is hopeful. We can tell he's hopeful because he's dreaming about basketball and roller skating and ice cream, all the things he loves. Here's one more. How do you think he feels? This boy feels angry. We can tell he has an angry face. What does your angry face look like? Grr. You know, there are lots of different feelings, and all feelings are normal. Kids have feelings, and grown-ups have feelings, and there are no good or bad feelings. It's what we do with our feelings that is the most important. Now, sometimes things happen around us that make us feel afraid or worried or scared or even angry. And sometimes those feelings are a little overwhelming. So I'm going to talk to you for a few minutes about something called coping skills. Coping skills are what we use to help ourselves feel better when we feel overwhelmed. Now, if you can picture a big umbrella, coping skills are like an umbrella that protect us when we feel overwhelmed. The very first coping skill that I want to tell you about is talking about your feelings. You know, you probably have some grown-ups in your life that care about you and love you, but they don't always know what you're feeling. So it's so important that you talk to the grown-ups in your life that you trust and that care about you so that they understand how you feel. When you talk about your feelings, when you talk about what happened to make you feel that way, and maybe you think of ideas that could help yourself feel better, that is such a great coping skill. Another coping skill that I want to talk to you about is deep breathing. Now, there are lots of different ways that you can do deep breathing, but I'm going to show you one called 5-finger breathing. I'm going to show it to you and you can do it with me. Now, the first thing we do is we sit up nice and straight with a straight back and our body is relaxed. Now you open one hand with your fingers pointing straight out and you take the pointer finger of your other hand. And what we're going to do is we're going to trace our hand. So we start at our wrist and we go. And as we trace our hand, we count 1, 2, 3 up our thumb and down, 2, 3. And 1, 2, 3, up the pointer finger and down, 2, 3. And then 1, 2, 3, up the middle finger and down, 2, 3. And up the ring finger, 1, 2, 3, and down, 2, 3. And up the pinky finger, 1, 2, 3, and down, 2, 3. All right, we're going to do it again, but this time we're going to put some breathing in with the tracing of our hand. Now when you go up, we're going to breathe in. So breathe in using your nose. And when we go down, we're going to breathe out. Breathe out through your mouth. Now, you don't have to rush. Take your time when you do deep breathing. So ready, here we go. Up, 1, 2, 3. Down, 2, 3. 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 Up, 1, 2, 3. And down, 2, 3. Now, when you feel overwhelmed, deep breathing is a great way to calm your mind and your body and help yourself feel so much better. Here are some other coping skills that you can use. Here are some pictures. This little girl is riding her bike and this little boy is running. Both of these children are exercising. Exercising is a very healthy way to deal with feelings that are overwhelming. Exercise is great for coping with our feelings. This little girl is dancing and this one is singing. She looks like she is singing so loud. Both of these are great coping skills to deal with our feelings. Look, this child is coloring. Coloring and drawing is a great way to deal with feelings. And this last picture shows some clay or Play-Doh. If you squish Play-Doh or you pound some clay, that's a great way to deal with our feelings. That's a great coping skill. Now, there are lots of different coping skills that you can use. The most important thing is to make sure that it's a healthy coping skill and that it helps you feel better. Now, there are all kinds of different feelings that you may experience. It's important to remember that all feelings are normal. Now remember the things that we talked about. Talking to a grown-up that you trust, some deep breathing is very helpful, and then thinking about other coping skills that can help you to deal with feelings. Thank you so much for spending time with me today. I really enjoyed it.
Thanks, Ms. Hayes. All right, well, that wraps up everything for us here today on Education Station. We want to thank everyone who shared their awesome lessons, and we want to thank you for watching. We'll see you next time right here on Education Station.